say we want to return the shortest path also, right? Right now, you know, we returned the length of the shortest path, right? So let's say the question is, find, you know, return the shortest path itself, right? So let's say, for example, here, this was the shortest path. We want to return all of the, you know, the nodes that we cross, right? Like, let's say it will be 0 and 0, 0 and 1, will be 1 and 1. It will be 2 and 1, and let's say 2 and 2, 2 and 3, and 2 and 4. We want to return this as a shortest path. So we don't want to return only the length, or, you know, the length of the shortest path. So again, we don't need to change anything. Only we need to update which information, you know, when we use which information we need to save and store in the queue. Do you remember, you know, the previous problem, you know, we had counts because we needed to return the length of the shortest path only, right? So that's why, you know, when we wanted to append anything, any item in the queue, we update the count. Right now, we need one more element in the queue, which is a list of, you know, the pairs, right? So that's why only I want to update this guy. Let's say I want to erase these guys to make it a little. Okay. So here, you know, I want to add another, you know, thing inside of this. You know, we have, you know, source row, source column, and instead of count, I want to add it list or array. But right now we have only one element inside of this, right? So we need this, and this is current path. Current path. Because right now we have only one element inside of the, you know, the queue, and this is the initial value, right? And we have this guy. Only that's the first thing we need to change. And whenever we pop, instead of count, so I want to change the color actually. Oh yeah, I want to change the color to show you how it is changing. So here we will have SR and S source row and source column. Okay, so here, when we pop in the pop part, okay, here, queue that pop left ij, and the next element is actually current path, right? It is current path. So if they are equal, you know, I and j, my current node or current cell is equal to destination, instead of returning count, I will return current path, because we keep the current path inside of the, you know, this array. So we have the neighbors. Doesn't matter, you know, depending on the definition and the movements, the valid movements, we will update here. You don't need to change this. And also, if a statement is same, only when we append, we don't need to append count plus 1, right? We want to extend actually the current path and append in the output. So I will write, you know, the current path. Let me do the blue, you know, the red color. Okay, so I will write current path plus the current node. What is the current node? R and C. So actually this is in a concat, you know, we are adding inside of this. Current node plus one pair, because we keep, you know, pairs inside of this, right? You know, actually I have, I did, you know, the list. They should be consistent. R and C. So when I do the current path plus this, it means that, you know, this guy will be added in you know, we are actually extending this guy with R and C. This is the new node. Only I have to add this guy here, and this is my list. Append this guy. That's it. And then at the end, you will, you know, let's say we didn't find the answer. We have to return empty list because we didn't have any list actually for, you know, from the source to destination. As you can see, again, the structure is same. We need to add some new, you know, parameters depending on the requirement of the question inside of the queue. So inside of the queue, we add another element, which is an array that we keep the current path. So initially it is source row and source column. Whenever we pop it, in the next neighbor we want to push, we will push the current path plus in the current node. The current node is actually the row and column. Again, you know, everything is in it. Even if you have more, you know, requirements, you will say that some, you know, the objective is finding something else. We can, you know, again, change the information we store in the queue. And when we pop them, and you know, there is two parts. You know, when we push inside, we should be careful to update our metric here, updating. Also, when we pop, we have to be careful to pop and save, store all of the values in some variables. Again, as you can see, it is not really you know, difficult, but you know, this question, for example, to find the shortest path, and you know, they change, you know, the interviewers, you know, change, you know, there's some, you know, basic, some, you know, slight, you know, differences, you know, in the assumptions. But if you have this, you know, the idea about, you know, how you define, you know, the BFS, again, I'm repeating this, you know, because it is really important. So I saw lots of, you know, my students, they say, I know this, but, you know, I say, okay, you know this. Can you implement this in 5 minutes or 3 minutes? Because you have to be able to implement whole code in let's say in Google Doc, not, you know, in real in PyCharm or, you know, like in IDs, in 5 minutes at most, because in the interview, maybe you will have some more assumptions. So you should be able to implement the basic problem or the thing that you already solve it in 5 minutes, and then, you know, think about, you know, how to update it. So the key is to be fluent, being fluent in the problems you are learning. Learning is not enough. Being fast is really important. This is the key in the interviews.